Okay, folks. Next topic to talk about is refactoring. Again, you know we're in the mode of doing our quality construction practices, and the emphasis here is on construction, right? As we talked about with design patterns, which you should have watched first. With design patterns and refactoring, we are looking to inject quality, to put quality in to actually change code in ways, as opposed to our other um, techniques. Unit testing, static analysis, code review is about discovery. So let's talk a bit about that. And again, this one I'm going to try and be a little bit more agile. And design patterns themselves are not about an agile practice. I mean, everybody uses design patterns, whether you're an agilist or not. Refactoring, anybody can use that as well. Not saying that, but it's particularly crucial, I would say, to being an agilist. Some folks even consider refactoring as a replacement for traditional design methods, and I'll talk a little bit about that in here. It's not something I really agree with, but some folks think that way. I want to go back and talk a little bit about Kool-Aid for a couple of slides. Um, Collective code ownership is a Kool-Aid from Agile that talks about how everybody on the team owns the code. All right. Um, so, um, if there is a bad piece of code, and by bad I mean, well, some of it's talked about here. All our unit tests are green. All duplication in the code has been removed, cut and paste. The code is expressive. The code is simple. Anything that you consider with respect to internal code quality. In other words, the code is how we want it to be. If you are working in a piece of code, if you have to go fix a bug, if you have to go implement a new feature, and you have to open up some code, you didn't write it, right? You didn't write the original code, but you go in and look at it, and it's crappy code. It's not very good code. The internal code quality is not up to the level that the team requires. Then it's your job to fix it. All right, you don't go and make your fix and leave the other stuff alone and say, well, I didn't make that mess, so I'm not cleaning it up. Collective code ownership is the principle that everybody on a team owns the code. And I'll do this in your projects. I mean, when I look at your final projects, I'm not going to sit there and go, oh well, Bobby didn't write that part, so that part won't count against this project grade. No, everybody in the team's got to be looking at all the stuff that gets pulled into master eventually, because it's all your code. It's the team's code. It's not divide and conquer. So collective code ownership is another one of these agile team-oriented principles for the code. Second principle, the code is the documentation. And we've actually had some discussion on this on Blackboard, I noticed. And again, not everybody agrees with this one, but I'm just presenting as a different perspective. Um, Code itself, I mean, if you're a developer, that means you have an advanced technical competency to work in the programming language platform that your development team or your organization has chosen. And therefore, you should be able to read code just like you read a second language, right? You're an English speaker, you speak Spanish, you speak German, you speak French, whatever. Do you speak Java? Do you speak C Sharp? Do you speak Ruby? Do you speak Python? If you do, then you should be able to understand the intention of the code. All right, and what it does. So the code is the documentation itself. If you have comments, those comments can lie, right? Meaning somebody could say something is doing something when it really isn't. They could be things that are poorly maintained, right? Somebody went into defect fix, refactored something, changed something, and was in such a rush that they didn't change the comments. Comments are an admission that we could not make our code express our ideas. Again, if you're writing it, you would expect that whoever's going into the code in the future that you wrote knows the programming language really well, so therefore they should know how to read the code and understand what it's trying to do. All right. And again, some folks said, even in our project code, have said, well, there's no comments in here. I can't figure out what it's trying to do. A purist, an agilist might say, well, you speak Java, you should be able to understand what it does. Now, if you can't, then maybe the code was poorly written in terms of its intent, but you should know what to look for, and you should know how to parse that, and you should know how to read it. And you might say, well, how do we do that? How do we make our software more expressive? Well, one way we just talked about, right? This is the code as a documentation guide. It kind of goes hand in hand with design patterns, right? If I put in let's see, an example from us. If I had put in a builder to manage creation of my objects, and I named the thing builder, then I should know what it does. If I did an observable, right, as part of things, and I extended observable out of Java, then I should know, I know what that's going to do because I understand the observer pattern. So that's an example of the code itself being the documentation. Again, I understand it's a bit controversial, and some folks, I really want those comments, and folks have that in their coding practices. But I see a number of agile shops, and again, I think I told you earlier in the semester, I worked with one really brilliant programmer in particular in industry who was just adamantly against having comments in code because he said that means that means you're being lazy. That means you're not writing your code to be intentional, to express itself and what it's supposed to be doing well enough. So it's kind of an interesting perspective. All right, some more Kool-Aid, and this is some of the language that appears in different places in Agile that I really love. I enjoy reading a lot of the Agile books because of the way they're written, and I love the verbs in them, so I underlined them. Right, XP is extreme programming, and again, a lot of these practices, the coding level practices we're talking about, the construction practices, became popular out of extreme programming. But think of it, it's just another agile practice, just like Scrum. But XP had things about quality construction built into it much more explicitly than Scrum does. In any event, so it says extreme programming refactors mercilessly, right? Boom, already there's an adversarial term, right? Mercilessly means I'm going to have no mercy on the code. I'm not going to stop refactoring until it's just the way that we want it to be. Another of this don't stop metaphors. Refactoring is aided by relentless testing and continuous integration. Right, so one of the things we just talked about last week and we're introducing on our projects is continuous integration and testing. Right, well, refactoring is aided by that because I'm getting now continuous per commit every night. Defect discovery activities, static analysis, hints on things. I'm basically getting. We'll talk about metrics soon enough. I'm getting consistent and continuous quality measures. Right. So now quality isn't this thing at the end of the waterfall in the box that I try to stick on the QA team, but it's something I'm relentlessly doing throughout the development life cycle, right down at the detailed level. And I think that's really powerful metaphor as well. And then the last one, and this is my favorite out of all the agile things I think I ever read, and one of my favorite quotes. This is my favorite. Refactoring takes courage, and we're going to spend time on this at the end of this deck and talk about why it takes courage. But the short version is it takes courage because for you to refactor something means that you're not going to actually modify functional behavior of code. You're talking about internal quality improvement. So you're basically asking to spend time, which equals money, in improving the internal quality of the code without modifying its externally visible features. That takes courage to do in the face of time pressures, in the face of deadlines, in the face of management breathing down your neck, in the case of threatened schedule or budget overruns. All right, but I love one of my favorite quotes: "One man with courage makes a majority." Effectively, this is a part where a developer has to be stubborn and say, "Look, for us to meet business outcomes, we have to stand up and refactor this code and improve its internal quality." And we're going to talk more about this at the end, so I think I'll leave it at that for now. Let's talk about what refactoring actually is and how one goes about it. So again, defined the act of improving code design and low-level code design in place in the code, right? So I'm not going to go out and do a big modeling and refactoring is not rework. Rework is some design solution has caved under the weight of new requirements, new technologies, new whatever, that the nature of change has become so large that, again, Super Mario's gone. Super Mario can't steer his way out of this one. We've got to rework something. I've got to go back and create new abstractions, new models, new coarse grain implementations. Refactoring are those micro implementation optimizations, all right? So you're improving code design in place. where it is in the code itself without modifying the functional behavior of the code, right? Which means the externally visible behavior, what QA tests for, what you black box test for, right? One way to think of refactoring at the lowest level is your black box tests in theory should not change, but your white box tests will, because you are changing how code works. You are rewriting the guts of some stuff at a low level. So your white box test, your statement, edge, condition, path coverage is going to change. But perhaps your black box tests don't have to change because you still have the same specification of the code. You should still have the same interface to it. All right. So when this says change unit tests, it's really you should not have to change black box unit tests. Whereas white box unit tests, you might have to change those in order to achieve the code coverage that you want. All right. We just talked about design patterns. One of the goals of refactoring often is to move toward a design pattern. Again, is that ability to express our code in intentional ways to make the code more expressive. So we may want to move toward one of those design patterns. And again, keeping with our Agile philosophy, Agile says, if design is good, then everybody will do it every day. In other words, you're always in this mode of improving the low-level internal code design quality. All right. So going to mechanisms. All right. Effectively, what we do when we are in collective code ownership and we're going throughout the code is we're looking for opportunities when we have to go into code for code that doesn't quite look right. All right. So how do you know code that doesn't quite look right? Well, the term, the analogy is code smells. Right? If the code's stinky, change it. So the metric is it's not a formal metric. We'll talk about formal metrics soon enough. But the metric is here's not only is there problems of patterns of solutions that we call design patterns, but there's also patterns of problems, things that we see repeatedly in code that are bad, bad practices. Somebody cut and pasted code and so forth. I mean, all kinds of things. So I'm going to give you some examples here. A lot of these are actually done by William Wake and here is Wake's refactoring workbook that you can work through. A lot of these, and again, this is I think this is, I don't know if this is a 2000 book or an updated 2003. So it's a little bit older now. But folks continue to extend this work. You see this out in the development community on wikis and so forth. And they talk about not just we talked about cataloging patterns last time. Now they're cataloging types of smells, things that they see are bad in code. Sometimes that's also under the anti-patterns. There's an anti-patterns book out there too from I think Manning Publications. That's really good. I'm going to talk about a few examples. I'm going to do this by example. I'm going to go through them pretty quickly. But there's a whole catalog of these things out there, just like there are for Fowler's refactorings that go with it. One type of smell is things that happen within the structure and responsibilities of a single class, and other ones are how responsibilities are distributed, and it's kind of blocking here, but smells arising from the structure and collaborations of many classes. All right. Some examples that, and I won't go through all of these, but duplicate code showing up, bad switch statements, methods that are too long, classes that are too long, improper handling of primitive data, primitive obsession in data classes, really long parameter lists, temporary fields, and a whole bunch of other ones. Let's take a look at just a few smells that are within classes and a few smells that are between classes. So an example, smell within a class. The smell is in a large class, that's the smell, keeping and adding one more thing to the class. So if you are working individually and somebody gave you an incremental feature to put in, you got your user story and you have a task on there to add your part of this new feature as part of the user story, and there's an existing class out there and you say, I can slap one more method on there. Right. Well, okay. So we have maybe originally we had a really nicely adhere class. We wrote a really nice class, but then you come along and you had to make and add a new method. Then somebody else came along and they had to add a new method because they had a new feature. Then somebody else comes along and they add a new method. Pretty soon we start adding more stuff that wasn't in there originally. Now, is that by itself bad? Well, it may not be, except for what happens is as we get larger. A class in an object-oriented system is supposed to have a singular responsibility. It's supposed to be about doing or abstracting one thing and doing it well. If we have to do many things and put them together, then we create an arrangement of objects and have them work together to provide that higher order responsibility for the system. In this case, as we add more stuff, the chances are over time that we're going to lose a sense of identity of the class, that responsibility it was supposed to do. And if it's really bad, then over time, over a long time, if it's been in the code a long time, you start looking at it and you start looking at where it's called from, and you start like why did somebody write it this way in the first place? Well, the point is that they didn't. They wrote this in the first place, and then other folks started adding in the crud. Okay, so it needs to be refactored, right? So and there's no formula, there's no recipe. There's only guidelines and heuristics for identifying refactorings based on different smells that you might encounter. But a common refactoring here might be extract a new class, right? Find features that reflect unique concepts and delegate responsibility to the new class. So instead of doing in that original class, take those extra things. I shouldn't have erased that. Take those extra things. Maybe they correspond to something else. Box them up and create a new class over here for them. Maybe there's some delegation that goes from here to there. Depends on what you're doing. But again, try and get back to that originally singular responsible class and what it's supposed to do. Another one related to size, long parameter list. So you start off with, an individual method. You may have some behavior implemented as a method, and it has, one parameter, P1. All right. Over time, folks started coming up with new variants for polymorphism. So somebody implements behavior, and I can implement this with P1 and P2 and P3. Right? And I can provide a third version of it, behavior, with P1, P4, P6, P7, P8. This starts getting long, and then the arrangements of these different things start to get different to handle. And what happens is when you start writing code like that, the first few lines of the method will almost always be about processing the parameters of the request. All right. After a while, it becomes very unwieldy, and you lose the intent of something when you have those really long parameter lists. So the smell is method grows occasionally with new parameters or has lots of polymorphic variants. Sometimes folks get away from the polymorphism. The reason why it says occasionally with new parameters is you start getting into, well, let's just write one version of the method. And I have a lot of parameters, P1, P2, P3, dot, 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 all the way up to P9, let's say. You have 9 parameters. And the initial part of the code says, well, if something, then I'll use P1 and P3, else if something else, I'll use P7 and P8, else if something else. And pretty soon you're writing this whole big long request processing part, and you're asking somebody to construct a parameter list, even though you may only be using certain subsets of those together at a time. Right? It gets very unwieldy. That's a smell. Some solutions for that, some refactorings may include one, preserve object. Instead of just trying to break the parameters out into individual values, maybe you objectize. So now behavior, its parameter, and really preserve object or introduce parameter object are kind of variants on the same thing. Preserve object says these original parameters may have originally been getters or individual data attributes from a small number of objects. Maybe P7, P8, and P9 represent RGB values of a pixel, and P1 and P2 represented the XY coordinates of that you want for a pixel. So maybe instead you just pass the pixel in, just pass the color in, all right, and have your object deal with it. The second is, if it's not like that and it's just a really long parameter list, because there truly are that many individual combinations of ways to parameterize the query, then introduce a new object called a parameter object so that I can implement behavior, and now I have my own parameter object, P1, and then P1 will have all the different methods and fields, and then you can even put all that conditional logic that was at the front of the method, all that big if-else, that will talk about valid arrangements of the attributes, all right, of that P1 through P9 we were talking about, and put those behaviors right on the object so it doesn't pollute the target method, right, in the beginning. So there's, depending on the origin of the long parameter list, the refactoring may differ. Let me go to the next one. A couple more smells within classes. And again, I'm just cherry picking a few. You have your reading from Fowler that's going to talk about code smells and some target refactoring. Speculative generality. That's guessing that, and this one, I included this one because this one's can be controversial. And again, from a background perspective, design patterns, refactoring, design patterns in the mid 90s, refactoring late 90s into the 2000s, becoming, so crucially important in the low-level developer world, while at the same time being architecture driven is coming about. Now, architecture is at the system level, and we talk about things like model driven architecture. Remember static analysis? We talked about MDA, model driven architecture. We talked about formal modeling, model driven transformation. So there's this kind of competing emphasis. At one level, we're talking about building better, training better chief architects and better designers and abstractors and better tools to start from those abstractions and produce code. So we're starting from the modeling perspective and going to code, right? Whereas Agile was coming about it and saying, start with a focused small solution on stuff and refactor on your way up to get to a bigger system. In other words, don't start speculating that you need all this big, poofy abstractions because you're going to die under the weight of it. You're not going to wind up needing most of it. When you need to do something more abstract, you're actually going to refactor your way to get there. And so that's why I wanted to choose this one. Speculative generality is representative of kind of these competing trains of thought. So speculative generality says, oh, I'm trying to solve a problem, but I know, if I just spend a little more time, I'll add some more flexibility on something. All right, so I'll start adding in a more generic parameter list. I'll add in a few more. I'll write some abstract classes and interfaces in all these things because I may need those additional abstractions later. You don't actually have a requirement for it. You don't know, but you think you do. All right, so guessing that flexibility will be needed. So sometimes you go in and look at a system or a set of code, open source code, or some other code from somewhere else, and you'll see all these abstractions. Somebody wrote an interface to something. That interface has an abstract class implementation. The abstract class has a whole bunch of concrete class implementations. And then there's a whole set of these things, scaffolding up a whole big set of stuff that you want to do to create this big monstrous abstraction, and your builder pattern comes along and cherry picks out of these things, wires them up particular ways so you're all set to go. Except for there's only one concrete instance of it. And you built all this abstraction when you only needed one concrete instance of it, right? Maybe you wanted to build a generic reader of information over a network. And so you build it for the network, and they say, well, I could do that for USB, I could do it for an email server, I could do that for over the web, I can all these different ways, but somebody only gave you one instance. There's an example of that actually in the real world. If you're a web developer, I teach this in the web development class, and we talk about Java servlets. Java servlets were originally had a generic interface for being able to support FTP servers and mail servers and HTTP servers. Well, at the end of the day, they dropped all that because the only thing that anybody ever really wanted and used it for was an HTTP or a web server. That was speculative generality on their part. All right, at a somewhat coarse level. At the low level, basically, it's the KISS principle, right? Keep it simple, silly. Do solve the problem at hand well, and worry about tomorrow's problem tomorrow. All right. So the solution for that is well, kind of the solution is actually to recognize you're doing it, not doing it in the first place. From a refactoring perspective, go ahead and remove the general code, the general method, the general class, all these abstractions, and again, solve the problem at hand. All right. Now, from my perspective, there are times when it's okay to engage in speculative generality, and that is if you're actually tasked with writing a framework, right? If you're actually tasked with writing something that is supposed to support many applications, then it's probably okay to go ahead and be a little speculative in your generality. But when you're writing an application, an application provides specific functionality for a specific class of users. All right. As an aside, I often throw these terms around. We have apps, frameworks, libraries, toolkits, systems. All right. I'm not using these by accident. They actually mean slightly different things. In fact, the best thing to do is, again, if you get this book, the first 30 pages here toward the beginning before you actually get to the patterns. And when you get to the introduction section, you have about 30 pages. Part of the reason I love this book is this book has the best introduction to object orientation and, what is a framework, what is a toolkit, what is a library, what are these terms different. Why is that aside important? Again, when you're writing an app, you have specific functional requirements, things that you're supposed to accomplish. When you're writing a framework, you're trying to support a family of applications, right? You're trying to provide some reusable code for a family of types of applications, and therefore the generality should be there by definition. So part of understanding whether or not you actually have a smell or not kind of depends on what it is you're actually writing and being very conscious of the type of thing that you're coding for. All right. Another one. Let's be a little bit more concrete. That was a pretty abstract discussion, I know. Another one is duplicate code. Right. The smell is nearly identical or conceptually identical code. Right. Well, and how does duplicate code really happen? Well, folks often find the fastest thing to do is to cut and paste. All right, instead of actually refactoring something out and extracting code to a common private method if you're inside the same class, or I'm inside a file, you cut this code up and put it back down, right? And everything starts to look the same. And I can do that in my editor so fast that it's just easier because I'm trying to get done. Then let me go create a private method that does the common thing. And you might think it's inside my own class anyway. Nobody's going to see it. What was the point of putting a private method? Well, again, somebody in the future may have to come out and maintain. There may be a defect in your class, and they're only worried about their functional defect. But if you cut and pasted, they're not going to find all the other places, even in the own class, because they're not looking for it. Whereas if that is in one place, you put it in that private method, and it's in that one place, then when they fix it for once, they fix it for all. Same kind of thing, except for if it's if you cut and paste it across classes and unrelated classes, then you need to create some new class that puts that common stuff. Right? If you cut and paste across two, you got to take that common stuff out and delegate to it. And that's why sometimes you see, classes that are only at the package level, even private classes and so forth. I mean, they may exist and only have visibility within your framework, library, or application, not to the outside world, because you're just trying to optimize and again write the code for a specific responsibility in one place and use it throughout your application system or framework. Okay, some additional smells between classes. Smell, primitive obsession. Not enough objects, only primitives. This can suggest a real lack of strong domain modeling. Where you see this a lot is, say here, you see parameters to methods where folks are reasoning in Cartesian coordinates, X and Y all the time. They're reasoning in the raw RGB values, and they're passing them along. We talked about this long parameter list, which could be, another artifact of a smell of primitive obsession. You have X, Y, and Z, R, G, and B. In object orientation, some behavior. In object orientation, I shouldn't rely on the application to understand multiple primitives conceptually make up one abstraction. All right, I shouldn't have to do that, even if it's something obvious like addresses. Right, you're asking the application implementer to understand domain knowledge. These things should be wrapped up in an object, and you should be reasoning in objects, not in those primitives. Does that mean you're never going to use primitives in your system? No, of course not. There's always situations where the primitive makes the most sense. But again, for each one of these examples we're looking at, right, these are values that don't make much sense on their own. All right, those things make sense together as an abstraction of pixel colors or addresses. So go ahead and refactor them that way. Put them into objects and pass those objects around, even if you only need to use part of the object inside of the target behavior or method. Okay. Another one, feature envy. The smell, class manipulates data of another class. I mean, I see this a lot. Feature envy I see a lot with helper classes. And it's kind of I should get back to that, but it's kind of debatable. I mean, basically what we're saying is we have a class here, and it's got some responsibilities, and we've got some other helper over here, or some other envious class that all of a sudden it just keeps on making invocations to manipulate this class all the time, right? And so it may have a method like change address, right? And this is an address helper, and this is the address. Well, sometimes we're talking about factoring things out and trying to keep our classes focused. But sometimes if you have these things outside and their entire purpose is just to modify some target object, well, then maybe those behaviors just should have been on that object in the first place, right? So we start to see that. If it isn't the case that happens, and maybe there's some additional things going on, again, it may be an opportunity to refactor into yet another third-party class. But usually with this one, feature envy implies that somebody started with a one-off of putting a piece of code for convenience in some place, and then over time, this class became more. It wasn't intentional, in other words. Helpers could be a little controversial because a lot of times folks will create helpers as a way to try and keep this class focused, and meaning consciously they're moving behavior out into the helper to do things. And under the right circumstances, that's useful. But in a number of cases, it wasn't concretely designed as a helper. We just had some other class that just started once doing that, and then somebody added it again, and then somebody later, and over time, these things started becoming closer and closer aligned, particularly the dependence of this one onto this one. So you have to say, if you really had to add all that stuff here, should have those behaviors been over here in the first place? Right? That's basically what we're talking about with feature envy. So again, the solution normally is make better decisions about how to extend and modify the existing class. Maybe you can use a design pattern for that. Maybe you can use a decorator if you don't want to put it into the core class, or you don't have the source code of the core class. It's part of a library. Then you extend and decorate it, and you add those extended features in via the decorator pattern, as opposed to having this feature envy go on evolving this other class. Another one, divergent change, smell. And this was related to the single one we talked about over in the long class. Class picks up unrelated features over time. The solution extracts those related features to new classes. So we kind of already talked about that kind of thing. Effectively, it's kind of just a smell of, over time, one or more classes, and this one's under these smells between classes because this really should say classes. You could tell it's been somewhat implicit, but we talk about a single class having a single responsibility, and then we talk about arrangements of instances of those class, an object graph, making up a coarser grained structure that itself has a single but larger responsibility. So effectively, the large class we were talking about a couple slides ago refers to that single class, single responsibility has become fuzzy over time. And divergent change can talk about that single set of that object graph, that collective responsibility that they share when working together, getting fuzzy over time. And you may have to kind of refactor this entire structure. Divergent change sometimes can get into rework. It can go beyond refactoring. That might be the kind of thing where, I can't do that transparently. It's going to affect my unit tests because I have too many objects that I'm touching in order to do that. So this one can borderline on rework over refactoring. Another kind of informal metric, by the way, of this rework versus refactoring is, if you have to effectively branch and you're worried about breaking the build and a whole bunch of other external dependencies on your stuff if you refactor, then I don't know that you're really factoring. You're probably reworking something, because now you're changing public interfaces on things of objects that are shared across the system, not just the internal implementation of something. Okay. Sorry, I thought I lost my place there. You're asked different refactorings that you can do. Fowler's book has and I'm going to talk about a few refactorings, and I've already talked about a few of them in terms of solutions. I'm going to go through quick this. I mean, basically, Fowler's book, the refactoring book, I'm having you read chapters 2 and 3 in that book online. That book, by the way, is this book. All right, Martin Fowler, I've quoted him several times. He's a master practitioner, and you have several readings from him. Um, you know, his book has a whole list and lots of them, even more than design patterns, right? There's a whole list of these things on here. This book is the book that I'm asking you to read for this week, and a couple of the chapters in them, including, chapter 3, Bad Smells in Code. But he has a whole catalog of refactorings throughout the whole book. So, the point is and again, it's been extended by the community in many different ways. And I'm just giving you a very small tip of the iceberg feel of what some of these common refactorings might be. All right. Some of the principles when doing refactorings, remember, I mean, we talk design patterns and refactoring and talk about them together. I mean, we're talking about low level stuff. So the machinery, how you do it down to the code level, does matter. All right, it matters a lot. You can let the compiler tell you when you're having problems, meaning compilers are better with errors and warnings. You could do it with a red-green refactor with constant testing. Remember, with unit testing, we talked about test-driven development and red-green refactor, test code refactor. That's our red-green refactor approach. All right, which means basically refactor the first time, make the unit test fail, then make the code pass, then refactor again. We'll also talk next week about measures and metrics. So you can let your metrics give you information on your refactors. You can let your static analysis tools give you information on your refactoring. Very often when you do a refactoring, it's also a subject of a code review. Hey, I just refactored these 3 things that we've been using a long time in our code. I think the internal quality is better. I did that off on an experimental branch or a 0-point value user story branch, and I'd like the team to review them before we pull them into master, because it represents a new internal code quality for the entire team. You do want to rely on your unit tests, because your unit tests are going to tell you whether you've refactored appropriately, whether you've done, whether you have functional equivalence when you're done. All right, that's what your black box tests are going to tell you, is that you have that functional equivalence. Excuse me. Refactoring actions rewrite source code. It can be within a single file, can be across multiple files. Again, that's part of the machinery. It's going to be very low-level kind of stuff that you're doing. Refactoring actions preserve program semantics. Again, doesn't alter what the program does, what's observable about it. It affects the way it does it. Internal code quality, right? That's what gets improved. We'll return to that discussion. We talk about Courage again in a minute. Ideally, it shouldn't change a class interface then. In other words, when you refactor, your view to the outside world, you go into some class and you try to improve the code quality, you would hope that the public methods that are called by other objects out here don't have to change as a result of that refactoring. Because again, if you are introducing these kinds of changes, then what happens is very often you don't control how many folks may depend on you, and so you might have a lot of classes that can change. And again, now you're starting to get into rework, right? You have to rework a whole bunch of stuff out here in addition to yourself. So you're trying to talk about refactoring as locally being within a single class. Again, there isn't a formal definition. Some folks religiously will say if you had to change a public interface and other code has to change, you're not refactoring, you're reworking, you're doing something else. But remember, I mean, this is not a, I mean, it's a gray area. It's not a formal concept. But the implication is with the refactoring is that you do not have a broad scope of change to deal with, that we don't have to get the change control board involved and write new tickets for it. It's something that can be done in place, normally by an individual developer, in order to improve the code quality as they're visiting and doing other stuff in the code. As an aside, I kind of had a role in my development team in industry a number of years ago, and I basically, to present the argument to management, I said, you have to allocate that 10% of a developer's time is going to be spent doing refactoring around this code to improve it. And I'll get back to that argument in a minute as well. Refactoring strengths, and this is refactoring strengths in new code. And this is, and I kind of talked about this up front, and this is part, is to me more controversial. Agilists kind of believe, some Agilists believe in this kind of emergent design, meaning start with a small, focused, simple solution and generalize out to bigger, broader solutions. And that refactoring can be the mechanism for creating that higher order solution. Given the I think it's a little double-edged because if refactoring is not supposed to alter what a program does, add new features and so forth, just the way it does it, well, as you're creating broader abstractions, you are changing what a program does. So in any event, it's kind of controversial whether or not refactoring is really the same thing as exploratory or emergent design. Design that you build from the bottom up as opposed to building top level coarse-grained abstractions and then pushing them down to the lower levels of the code. Not a right or wrong concept. It's kind of a matter of again, Kool-Aid and interpretation and philosophy. Refactoring does facilitate, and really it's a hand-in-hand thing. All right. Refactoring goes hand in hand with unit testing, red-green refactor. It goes hand in hand with static analysis. You can rerun your static analyzers. It goes hand in hand with continuous integration and testing, because those dashboards should show the results of these things improving as you introduce refactoring. It goes hand in hand with design patterns. Next we'll do measures and metrics. It'll go hand in hand with that. We'll talk about defensive programming. It also, so refactoring, it can be one tool that can be used in conjunction with pretty much the whole range of things that we're talking about in quality construction techniques this semester. Right? No matter whether it's no matter the philosophical debate, I'd say the Kool-Aid debate about refactoring and the level of scope that it does, whatever it has, the resulting code should be of higher quality. All right. Again, that should show up in your continuous integration and testing dashboard, in your metrics, in your static analysis tools, in better code coverage, on your white box tests, in consistently green black box tests, and it's easier to actually maintain your black box tests and so forth. So let's talk about some example refactorings. And again, the book has all of these, and this is just to give you a feel, not a lot of the detail. So, for example, a code smell. Your code does repeated checks for no return values. So, you invoke a method. So here we're invoking a get plan. So I have some app out here, so there's some object out here that's holding on to a reference, and I'm asking the user for the user's plan, right? Beforehand, if I had that reference to user, I had to ask the user whether the reference I got back perhaps is null, right? Well, if I'm allowed to carry around a null, why would I have a null user reference? All right, what I'm presuming here is I had some user object declared of user, and then maybe I did a lookup of user. So maybe I had a behavior search my contact list for users, right? And so that user I'm looking for is named Joe, Joe Schmo. Except for that search feature, I searched for Joe Schmo, except for the search didn't return anybody, right? Well, typically if I'm going to try and do some behavior on that user, then I would have to check that user reference is null first. Because what I'm after is the user's plan, right? Maybe it's their work plan, maybe it's their course schedule, if it's a student, whatever. But so I'd have to make sure that the search returns something. So user equals the search of this thing. Now I got to check that search is null. So I'm trying to show you what the code might look like above this. And I got to check that the user is null before I go ahead and try and do an invocation like user.getPlan. All right. So what I want to introduce is that null user refactoring. Now in this case, when I did the user was null, I basically, what is plan.basic? Well, this is a static reference to a plan class. It basically means that there's a default behavior. There's a basic plan. So maybe if it's a student course schedule I was representing, plan.basic represents the, major map, semester 5. That's where, or 6. That's where you would be with 316. So maybe that's what plan.basic represents. All right, it's a default on the plan class. All right. Well, for me to use that, again, the point is I've got to do this null test everywhere because I may have behaviors that are allowed to return an empty set of things based on a query. Well, instead of doing that, maybe I could just return a null user object. Maybe I could change the search method to return, in this case, a new null user for this, and that's what S winds up getting bound, or I'm sorry, not S. That's what user ends up getting bound to, this variable. And if that's the case, then I can write this because the getPlan method will turn around and call getBasic for me. Right? So in my app code, and again, I know I make a mess of these slides, I know. In this app code, all right, this over here this is app side code. In this app code, I'm polluting it everywhere with all these if-else just to make sure I've got a valid user reference. Well, maybe I always make sure that user's not null by making a point to an instance of null user with all the defaults for something. So if I'm doing something according to convention or according to defaults, the null object pattern is actually a really useful solution to that code smell of putting that user test of null everywhere in my code. Another one, refactoring, a split loop. All right, in the split loop one, now realize, what do I have going on here? I have this simple loop that's doing an average age and doing an average running total for a total salary, and at the end I've got to do some post processing in order to get the average. All right. Now this looks pretty innocuous. In fact, this is the way I was taught to code, to look for opportunities to optimize by bringing two things that are going to iterate over the same thing, in this case some array, and take those two things and put them together because it's going to make the code go faster. Well, things evolved. I mean, runtime's so much faster, and realize that if I split these two loops up here and here, then I have more specific intentional code, right? This is the total, and this is the average. And there's no confusing them, all right? And it's intentional. I can look at this line of code and know exactly what it's doing, as opposed to this, I'm trying to do two things at once. This is not intentional. This is optimized. At a very low level, it's going to be faster than this. This is not optimized, but it is intentional. All right. This one is going to be 2x through the people array. All right. But as you learned with your big O notation, the big O is still big O of people.length for both this way and this way. All right. So now the computers are so fast, now that we understand things, optimizing this at this level, I'd rather sacrifice that micro optimization for the intentionality of doing these things. So I'd rather take things and split them into the two different loops. All right. So it's kind of, thinking has evolved over time, is what I'm saying. In my day, I was taught to actually look for opportunities to do this. Now folks are saying, no, keep these things separate. Computers are fast enough that I'll take understanding what each one of these loops do and its dedicated purpose over the very micro optimization I get by combining them into one. All right. So that's a smell, a loop that's doing two things. And the solution, split it into two loops, make them each easier to understand, and open your door to further refactoring and optimization. So for example, these two things may actually wind up going out into two different behaviors, two different methods. I may have print, so for example, I could refactor into print total salary and print average salary. right? Move those two loops into their own individual methods, and then print values could just call each one of those, for example. Same thing with a temporary variable. You may have a temporary variable assigned to more than one place. Again, this was something I was taught to do. Was actually to reuse variables inside my call stack to keep my call stack smaller. If you're an embedded systems program, you may actually still do this because we were worried about RAM. We were worried about call stack space. So we would start. We would create a int temp, right? And in the top of our method, we may do, temp equals, some calculation, and later we may say it equals some other calculation, and I use it locally in these little code blocks. This might be a loop body, this might be a switch statement later, and I use the same variable in two different places is the point. Some folks even create class member variables for those temporary calculations, and that's absolutely incorrect. But the point is, why would we do this in embedded systems? Why did we do these in the old days? Well, literally, I was trying to save the 4 or 6 bytes that I would get by not having to create a second temporary variable. But the problem is, obviously, if somebody comes along and changes something or rename, let's say somebody says, okay, I'm going to call this temp2 now, and somebody left a reference to temp down here, they'd be using the wrong value. All right, it's hard to maintain code because this won't get a compile error because you're using it in more than one place. So again, the solution here is memory space is cheap. Now for each individual temporary calculation that you do, loop counter calculation, you go ahead and you create a new temporary variable. All right, so I have two different, beforehand I had temp equal to this value. I output it, and then I change temp to equal this value, and I re-output it. Instead, I'm going to create a more descriptive parameter that is going to be output, and then I'll create a descriptive area that's going to be output. And yeah, I'm using doubles, and I'm using 2 of them instead of 1, so I'm losing a small number of bytes. I'm asking for the call stack to store a little bit extra information for a very short period of time. But again, modern compilers, modern runtime environments, we don't have to do that micro optimization anymore for those kinds of things. Again, unless you're working on very specific embedded and micro architectures. This one I want to take a second and talk about, and this is one that's again in the design patterns book. I'll hold it up again. And the goal here is refactoring to patterns. So we talked about design patterns as representing this higher order vocabulary and this collective experience of master practitioners, of senior practitioners. So a lot of times when we refactor at the low level, our goal is to actually turn something that is written in an ad hoc way, a one-off way, and actually target a design pattern. Right? I want to take this mess of code and turn it into a singleton, into a builder, into a factory, into a mediator, into a facade, all right, as we talked about last time with design patterns. So here's kind of a specific example of that. Let's say your problem or your smell is you have an object representing a specific physical resource, only one of a kind thing. It may be this digitizer, it could be this headset, right, as a USB device. When I have a hard resource for a system or an application, usually I need to protect access to it. In other words, when I'm modeling in my application, I don't want to have multiple threads, multiple clients being able to access or instantiate multiple internal memory software objects that are the abstraction of the physical object, all right? Because I can get in problems with the state of the object, right? This object, my headset, is currently in mode where it's picking up my voice and transmitting it through the USB into the computer that's getting translated into this video, and the program that is Camtasia that's recording this is picking up on that. My Smart Ink application is picking up on this digitizer, again, into a different USB port, but there's only one of these. I don't have another application trying to use the same Smart Ink, the same digitizer pen at the same time. Same USB. I'm not recording to two different programs right now. I'm recording to Camtasia. In fact, it tells me before I start one of these recordings, make sure you don't have, system screen recordings on or something else that would be using the same shared USB device. Not always the case with USBs, I know. There can be some USBs that are sharing across multiple programs, but I'm saying in this case, we want to have one software object representing the one physical object in the real world. How do you do that? How do you actually control how many objects are created? We can apply the singleton pattern. So our problem is you have an object representing a physical resource. You want to make sure you only have one actual object in memory, one software object to correspond to the one physical object, and that you can manage that object's life cycle. Now, in straightforward code, you might say, okay, I want to read things off a USB, so I'll just go create a new USB object and go ahead and read from it. All right. Well, again, this is application code. This means that our USB is responsible, our USB object or our app object is responsible for instantiating the USB. All right. Now, what happens if I have multiple threads that do that? That means that if I have two different threads of execution in my program, or even two different processes, two different programs, then they create USB objects, and they're both trying to read from the same underlying hardware that represents something, right? This could be my USB interface to my my digitizer pen. I'm a horrible artist, as you probably got a picture of this semester. So now I can have a conflict with two different programs or two different threads trying to talk to the same thing, all right? Or, even if it's a single threaded one, realize that when this USB, if this is newed up, then this is created on the heap, and which means when this variable u goes out of scope, at the end of this curly brace, all well and good. U is targeted for garbage collection, but in a language like Java, where you don't control memory management, you don't get to control when this is garbage collected. Maybe you said, I'll be clever. I'll clean up after the USB in the finalizer, that method that's called when an object is garbage collected, removed from memory. However, you don't control when something's garbage collected. So maybe the next time you re-entered this code, that USB object hasn't been reclaimed yet, and you're locked out of the object, or you get the USB into the wrong state. So in any event, your solution is that you want to make sure there's only one software object in memory. But if you make a public constructor, you can't control that. Anybody can call it. So how might you do that? You apply a singleton. So now this is in the app, again, this is app code. In the app code, well, actually, let me start with the USB class. In the USB class over here, this is the singleton. I'll ensure there can only be one instance by creating a private static member variable. By having a private constructor, I can no longer do something like this, all right, because my constructor is private. So if it's private, that means only the class can control it or call it. So how would I do with that? I mean, what's the outside world going to call? Well, you create a new static method that is public that says, let me get an instance of the USB. And by doing that, I can check that my static class member variable actually has a valid reference to it. If it doesn't, then I create one, and that's what I return. If I already have one, meaning I previously had created one, then I'll just go ahead and return it because this test would fail. All right, so read that code a couple times and understand the nature of static versus not, and then you realize that you can change your client code over here to do a static invocation of get USB. Now, of course, I don't have a parameter here, so I would have had a compile error. I should have settings in here, but you get the gist, right? This thing is a static invocation, so it can be called at the class level. I don't need an instance, and it's going to return an instance that I'm maintaining. All right, in a single case. And a singleton only manages the creation of the object. You may actually do more fancy stuff in terms of managing the life cycle of objects and the states of them. Replicating this pattern, you can create pools of things and so forth. This kind of gives you an idea of, hey, I can guarantee you now that there's only going to be one instance of USB right here at any time in memory. All right. So those are some examples of refactoring. Again, it's somewhat difficult in a discussion in a lecture because I can show you examples of smells and refactoring over and over in code, in lecture notes before you get the hang of them. It is something. This is one of the things I'd like you to keep in mind as you go forward in your professional career of software development. You're going to see more and more smells. You're going to see more and more refactoring. Part of the reason I wanted you to work with existing code is because I wanted some of the code to be ugly, and for you to identify, hey, I had to go in and look at this code and it had no documentation. Is it intentional? Is it smelly? Do I need to refactor some of it? You certainly can refactor code that you've already made in your project, but I would hope when you go do refactoring in the context of your project that you actually look for opportunities to refactor the code that you see inside that open source project, and not just your own code that you wrote. Opportunities for improvement of existing code. All right. I want to switch gears and heading towards summary, go back to some of the stuff I was alluding to at the beginning of the presentation, particularly the things around courage. And the thing is this, working in software development, you often be asked to work under tight deadlines. You often be asked to work under pressure. Sometimes your project managers may or may not have a lot of development experience. It certainly, to me, helps when they do because they understand the issue. But the fact of the matter is it's a profession where very often the time to market is a very real business concern. You need to work fast. You're trying to build quality. But we're trying to say at the same time that you have collective code ownership and you should stop what you're doing when you go into messy code and refactor it and improve the internal code quality. That's what collective code ownership says. Well, management will come back to you and say, well, you told me you're doing this refactoring. And, I've the last 3 stand-up meetings you said I'm refactoring X, Y, or Z, right? But we're not seeing, we don't see any functional change in the code. The code you're talking about, it's been in there, it's working, right? It's working. You're refactoring, but you're not changing anything observable, right? You're just improving the internal quality, and you're trying to tell me that that this is, this is something that'll pay for itself down the road. When you spend hours on a project and you build the company, you build to the customer, I need to see observable code, that's working. Need to see what I consider to be tangible benefit. All right. Well, you have to understand management's perspective. Something that's in there and appears to be working, and you're spending time, you're spending money, and not producing any observable change, and again, it's like they don't understand the value for it, right? And very often business value is valued in near-term deadlines of things that you have to release, and you can worry about changes down the road. The real conversation that needs to happen in your organization is around the common understanding of what's called technical debt, right? When you get into doing something, and we talked about the nature of change earlier with change management, and we talked about sometimes in the change control boards, you might say, well, you need to do something faster and just do a workaround versus doing the best solution. When your organization makes these decisions, and sometimes they make them implicitly, other times explicitly, those decisions I'm talking about is when something is not done right the first time, right? When it's not done right the first time, what that means is there's a better way to do it. And in the future, we want our software to be done the best way we can do it. So if we don't do it right the first time, we're basically saying we're incurring a debt for the future. Now, that could be an explicit decision, which means the manager says, okay, I understand it's not the best solution, but do it that way for now. We'll get back to it. How many often have you done this just individually? You had this conversation with yourself. I know this is not the best way to do it, but I've got to get this done. I've got to get my homework in. I've got, other things demanding on my time. So I'm just going to do the quick and dirty way, and I'll come back to it later. All right. The problem is later always seems to, 1, never come, and 2, when it comes, it's more painful than you originally envisioned. Why? Because other code is piled in and is now dependent on it. So now instead of just refactoring, you may have to rework. Sometimes it's implicit. Sometimes you just didn't know any better at the time. You're new to Java Swing programming. You're new to Android programming. You're new to whatever kind of programming. Best practices have evolved. Who knows? Maybe, for whatever reason, you or your organization simply didn't have the capability to write it the right way the first time. So it can be implicit or explicit. The point being, though, is you incur this just like credit card debt. you incur this debt on on future work and on future expense that your organization is going to have to do. And not only that, but just like a credit card, you have a high rate of interest, meaning the longer that smelly code sits in your code, the more likely it's going to be baked in. More things are going to be tightly coupled to it, dependent on it, and your ability to rework it, the ability to refactor it, is going to be limited. Um, Effectively, part of collective code ownership, the economic argument is trying to say is that you're basically spending time paying off the interest and hopefully the principal, really, on that technical debt. Meaning by solving the core internal quality concerns and getting things back to being done the right way, that you're preventing those future interest charges from happening. You're prevented from being on the wrong side of a slippery scope of the poor quality and maintainability of your code. That's effectively the economic argument, and to the point where folks have started to come up and come up with models for trying to model technical debt. When you make that decision, you understand how much cost you're incurring and how much cost it will result for you or your organization down the road. That's difficult to do. It's a research problem. Some folks have models out there that they try and do. I would say from a practical perspective is if you are at least conscious that you are incurring technical debt at the time you incur it, even if you have to. We'll talk about this in a second with the technical debt quadrant. At least you aren't fooling yourself. I mean, you knowing is half the battle, GI Joe says. At least you know you're doing it. You kind of know that you have that debt in there. Hopefully, you can negotiate a term, maybe a stabilization sprint. Maybe you can, well, like I said, I mentioned before, I negotiated with my management a 10% recurring cost on every developer to go in and improve the current code quality. We had acquired a product through a merger with another company, and the code that company gave us actually was terrible. And so we were trying to incrementally improve it while still building new releases on it. Very tricky business. So in any event, though, your organization needs to understand the concept of technical debt and needs to have a strategy where they understand how they're going to pay it down or even how to avoid it. All right. Again, to do that, refactoring takes courage. Developers need to say, it would be. I have the courage. I know that it would be faster to cut and paste this. I know doing it this way and introducing a smell, it's faster. I can do it that way. We'll get more functionality out. To hell with the future. To hell with what it's going to cost later. But in the principle of collective code ownership, in the principle of individual courage, you need to stand up and say, this is just not the right way to do it. This is the better way to do it. We're going to incur too much debt. Now, again, so I want to go to the technical debt quadrant next, which came off of Fowler's blog posting. Does that mean that it's the developer's sole responsibility to say, I'm just not going to do code that way? No, it isn't. I mean, there are always business situations under which even the rushed solution is the correct solution. So that's what the technical debt quadrant's about. It seems like everything that business majors work in seem to be quadrants, SWOT analysis, but this is the technical debt quadrant. Maybe your manager would understand this. On the x-axis, we have these concepts of being reckless or prudent. Reckless meaning, damn the consequences kind of thing. Prudent meaning I'm going to be very aware of the consequences of my actions, versus on the y-axis being either deliberate or inadvertent. All right. Starting in the lower left, inadvertent technical debt comes from basically ignorance. What's layering? Well, layering is an architectural style, like I was talking about with Garland and Shaw's book at the end of the design patterns lecture. So layering is a design strategy, if you will, in the code for managing tight coupling and managing dependency between things. Regardless, whatever the concept here is, basically something saying, what is that? I don't even know what that is. Meaning they didn't consciously decide to introduce technical debt, to introduce a poor first solution. They didn't know any better. All right. But notice how this is also in the reckless column. All right. It's inadvertent reckless. I mean, this is the worst column, right? Why is this the worst column? Because reckless means it's very damaging. Inadvertent means I didn't know about it. The reckless part says we really shouldn't be ignorant. If I didn't know what layering is, right? If I don't know what swing is, if I don't know then maybe I shouldn't be doing work in that area in the first place. I don't have the right resources. I don't have the right organizational capability, and we've got a serious organizational problem. Because we shouldn't be ignorant about this. We should have the competency to understand that we don't know how to build the best solutions in this space. Your organization doesn't know how to build the best solutions in a space. You have to ask why they're working in that space in the first place. All right. Let's stick with reckless. So let's go up to so you didn't know, but you should have is basically inadvertent and reckless. Let's talk about deliberate and reckless next, right? Deliberate, explicit decision. We don't have time for design, right? This is to me the red. By the way, these are my annotations on Fowler's diagram, and the actual concept came from Ward Cunningham. The easy excuse. I mean, the number of times I've gone and had to talk either with an individual developer or a code reviewer or with the team, said, it's just kind of the general blanket excuse. We don't have time to do that. We don't have time to do that design. It's basically saying, maybe there was a complex problem. You had to properly design something out in order to get that array of objects that made a component again, and this whole stuff we've been talking about. We didn't have time for that. I didn't have time to know whether or not I was cutting or pasting, and look for a common solution and refactor it into some third-party class. I don't have time for that, right? And that's a conscious. So you're aware it's a smell, but you deliberately decided not to deal with it. It's reckless if you're basically using that as the easy excuse. You're basically using that as a way to get out of doing work that maybe you don't want to do. All right. That's different than, say, again, back in the inadvertent space over here, where we're being prudent. All right. Prudent says is we at least have a continuous assessment process to try and address our own ignorance, to get better competency. All right. So now we know how we should have done it. All right. You didn't know, but now you do. That's a little different than this one. All right. And you can ask these kind of questions up front as you go into a new design space, a new domain space. All right. So now we know how to do what we should have known how to do before. And then the last one, our convergence into the best space. And again, this isn't necessarily the best space. I realize this is all about technical debt, which means in every situation here we have technical debt. We're talking about the reasons why we got there and whether or not those reasons are conscious or not, deliberate or not, and whether or not they are reckless or prudent. Meaning, at least you made an educated decision. You made it with full awareness of the consequences, and therefore, you can manage your way around it. You do that with debt in all, in everyday life. You buy a house and you take out a mortgage, right? If you're smart, you take out a mortgage that fits within your future budgetary constraints. You're consciously taking on the debt, but you're doing it in a prudent fashion, doing it in a way that you are confident that you're going to pay off and keep your credit rating high and all those wonderful things. So we're talking about the same thing here, right? There may be a prudent case whereby that you have to ship now, right? We have to ship now. If we don't ship now, we're not going to be able to compete in this market at all, and we're going to have to deal with the consequences of that. Right? The business reality means you have to ship something that is not maintainable, right? And then the question you have to ask yourself is, will you have that courage? Will you allow the improvement of the code quality later after the fact to pay down that debt? All right. And again, that's never going to happen. Well, maybe you made the necessary decision, but eventually you're going to fail as a business because that code quality will come and bite you. All right. Those are the trade-off of those two factors shown as a technical debt quadrant. Summary of refactoring, and really refactoring with design patterns. And again, there's you can go read tons of blog posting. There's a lot of developer community. There's a lot of with refactoring, refactoring in particular, not so much design patterns. There are some different trains of thought, if you will. Refactoring is sometimes thought as in-place design or just-in-time design. And again, this is a perspective I don't really agree with. In other words, I don't really agree with this, just expect for an elegant design to evolve for something at the system level. Now, again, when you pay attention to the machinery at a low level, refactoring can be very useful. But if you are really dealing with complex extractions at the system level, at a larger level for your application, involving a lot of different classes and objects, brand new things that you have to design, often a new development, there's nothing in Agile that says you can't go and do that design. That has to be emerged at via refactoring. Agile says you should do as much design as is necessary and no more. That's that concept of ceremony that we talked about before. So I guess what I'm saying here is, when you need that full design, do it that way. Create the UML abstractions if you need to, or do whatever form of design, your data model, whatever it is that counts as design. You got to go to the whiteboard and create those common abstractions for your team to do. Then go ahead and do that if it's required by the project. Don't rely on saying, well, just go do a first solution and then we'll just keep refactoring it. Eventually we'll wind up with an elegant, full-blown system design. I personally don't agree with that. However, again, the principle that folks are trying to get here is to get away from that speculative design of over designing something, getting into design paralysis, or what's called analysis paralysis, where the team is creating huge scaffolding of code that they'll never use, or is debating all these design decisions and won't get over to their ID and actually start writing code. Again, that inhibits your momentum, creates a sense of inertia on a team that you don't want. So I do understand just do it and refactor it. From that perspective, but again, there are times when full-blown design is required. Refactoring is an expression of the collective code ownership and courage agile values that we talked about. The code's a responsibility of everyone, and that's exactly how I'm going to treat it on your team. You shouldn't be going into a code module, looking at it and thinking, boy, that's a mess, and not do anything about it. Now, do I expect you to refactor all that open source in your team project? No, but if you're going in and code reviewing, unit testing, modifying something, then you should take a look around and understand whether your teammate wrote it or the open source community had written it, whether or not that's code that's in need of refactoring, whether that code is smelly. And then, you have to have the courage to alter schedule expectations in the name of that quality. That's going to happen for you folks. You might think, well, we really got to get this project out for Dr. Gary and his class, so let's just keep banging out functionality, and who cares how ugly the code is? Well, I'm going to read the code, and I'm going to look for smells, and you have to have the courage on your tag as Scrum board to have that 0 point story that says, or that reaction to a unit test or static analysis says, we're going to go fix that internal code quality instead of spending those hours, over implementing yet another feature to make look like we had done more stuff or accomplished more stuff. And it's a balance. I mean, refactoring is not a silver bullet that makes up for things. You still have to do the work. And it can be difficult. Remember our burn downs in Agile. When we're done with something, we like to put it in the done column called done is done. We've counted the story points and to keep moving new user stories across the board. And now we're saying there has to be something on the board at all times, some task on the board that says, I'm basically going to be refactoring and improving internal code quality without adding any story point values. We've just added a dampener on our user story burn down chart. At a time when we were trying to use Agile to get faster. All right, so there's a bit of conundrum there. It is a challenge, and Agile's answer is to say you've got to have the courage to do it, because at the end that code won't be maintainable. It won't be quality oriented. I'd also say too is again thinking to the technical debt quadrant, you have to think in terms of what is it worth it to do. Sometimes there's cruddy places in your code, but it doesn't matter, or it doesn't matter that much. That you can manage your way around it as opposed to fixing it. That's not the pure Agilist perspective. They'd rather always see you fix it and improve the internal code quality, but maybe this feature is going away. Maybe you're going to a new version. Maybe its lifetime is going to end anyway, or maybe it's just not called that much. So even for your project teams, there's the where and when question. How much time can we spend refactoring? Where do we need to do it, and why? And it goes hand in hand with the defect discovery techniques where, what code do we unit test, what code do we code review, what code do we run static analysis on, and how's that going to translate into something actionable where we're going to turn around and improve the quality of the project. So I mean, I'm certainly going to require you to go in and refactor in a couple places in your code, and you could take the perspective of, okay, I need to refactor in a couple places, and I'll check that box. Or you could practice the agile values of collective code ownership and courage and say we need to refactor this code because otherwise that quality, again, everything goes back to the triangle, right? The quality aspect versus the cost aspect versus the schedule aspect here. Yeah, I've got to improve quality, I got to spend more time and cost. That may suffer the schedule. That's a 2 out of 3 relationship that the triangle has. But I'm going to have the courage to do that, and the schedule is going to have to wait. Have to have a strategy for it. It's not an easy problem. Putting labels like technical debt on it and refactoring and so forth doesn't make it go away, but hopefully it means that you can have a strategy and a conversation around it between development and management on what you're going to do there. And then finally, I mentioned already, so real quick, refactoring is only of limited use in isolation. In other words, it's not really that you just go in and say, I'm going to refactor something today. It's you have to make that intelligent where-when decision, and you do that guided by your defect discovery practices. Again, the white box unit test showed that it was really hard to get good code coverage. The code review revealed that some of your senior mentors or some of your peers even suggested better ways to do the same thing you're doing, but better ways to do it to improve the code quality. Static analysis picked up on some automated ways of doing the same thing. Next week when we do measures and metrics, hey, I've got a high psychomatic complexity in this. Is there an alternate way for me to write it to bring that psychomatic complexity down? I have poor cohesion, I have high coupling, all these kinds of things that are tools and our other defect discovery things that give us indicators that we have poor code quality. They may suggest a smell that then refactoring can help you go fix. All right. Sometimes it's other things. Sometimes rework is not refactoring, but sometimes you say, okay, I understand what some of these tools and these processes are telling me, what these practices are telling me about my internal code quality, and I can apply refactorings X, Y, and Z out of the catalog to address those issues. Okay. And again, finally, target your design patterns. Trying, by creating and using that higher order vocabulary, those higher order coding abstractions, you have an ability to show low-level code quality much more intentionally and in much more apparent fashion. All right. So that's design patterns and refactoring for this week, and that's our second to last topic. Next week, we'll talk about defensive programming and measures and metrics, and that will be it.